let us get into today's lesson. So today, like I say, what we're talking about or what we're looking at is number patterns. So if anyone wants to raise their hand, can someone tell me what is a pattern? You can relate it to numbers, whatever, but overall, broadly, what is a pattern? You can put it in the chat if you don't want to raise your hand. But my question to you is, again, what is a pattern? Daniel?
A pattern is a repeated arrangement of like numbers, shapes, colors, and everything else.
Okay, very nice. All right, so guys, firstly, what I like there is it is repeated. We are repeating the same rule or the same mathematical operation from one term to the next. And what was very nice there is that it's not necessarily just numbers that we look at. Sometimes we look at pictures. So like, I'm sure many of you who've done this already will see like in your textbooks, they'll often say so-and-so has got matchsticks or toothpicks and they've made a picture with the toothpicks. And so we need to also be able to look at pictures or images and recognize a pattern that's going on. So a pattern, and I'm hoping I remember all the words, is a repetition of the same procedure or the same rule to get from one term to the next. Now, when I talk about a term and number patterns are the numbers in our pattern. So you'll see now when we do some examples, I will point out to you what terms are. So these are the numbers in our pattern. And as long as we keep repeating the same rule or the same procedure, we are getting a pattern. We're doing it through repetition. So that's why I also quite like this idea of images. If you just keep repeating sort of what's happening in an image over and over, you get a pattern. And actually we get some really, really cool mathematical patterns and sequences that we can represent as images. I thought I had a picture here, I don't. We have, I'm now just going on a tangent because now I've thought about it and I think it's really cool. We have, I don't know how many of you know the Fibonacci sequence, which is a number pattern. The Fibonacci sequence is a really cool number pattern whereby you sort of add consecutive terms. So it's, just had to remember it's 0, 1, 1, 2. Oh, it's been a long time. 3, 5, 8. So the Fibonacci sequence goes like that. You don't need to know this. I'm just taking a tangent. It's really cool. 0 plus 1 gives us 1. 1 plus 1 gives us 2. So basically, that's a really poor way of doing this. If we add consecutive terms, we're getting the next term. So let's go like this. 0 plus 1 gives me 1. 1 plus 1 gives me 2. 2 plus 1 gives me 3. 3 plus 2 gives me 5. 5 plus 3 gives me 8. 8 plus 5 gives me 13. Where I got 11 from, I couldn't tell you. And so if you keep adding the terms before, you end up with the sequence. Now, because mathematicians are super, super smart, they actually came up with like a visual way to represent the Fibonacci sequence. And it's actually in a spiral. And we see this so often in nature. So this is the Fibonacci sequence as a picture. And it spirals like that. And if you think about like just in nature where we see these sorts of things, we see them so often. So as a realistic sort of image for you, if you think about, I want to say tornadoes, geographers, you can help me out here. If we think about tornadoes and tropical cyclones, that is the spiral representing the Fibonacci sequence. If you think about like some seashells and the way that they're created, Fibonacci sequence. The pattern in some leaf growth or some plant growth, spiral, Fibonacci sequence. So the Fibonacci sequence is one of the most like famous number patterns that we have. And it has a lot of applications to a lot of different things across, like outside of just maths. So, excuse me. So this is one of the like really famous number patterns that we get. And that's essentially what we're going to explore. We're going to explore patterns, how we find these patterns, what am I repeating, what am I doing to get from one term to the next, right? So you don't need to know anything about the Fibonacci sequence. I just, all of a sudden pops in my head and I think it's a really cool sequence. So I'm explaining that to you. So Kwando also put there on the chat, it was in an exam question. Teachers love to put the Fibonacci sequence in an exam question. So now you've seen it, hopefully you know a little bit more about it, which means that you can actually go and answer these questions, but it is one that teachers love to put in exams. All right, but let us start off small, work our way up to the Fibonacci sequences of number patterns. Right, so if we look at this first pattern that we have here, and I just want to bring this down to the next line so we can see what's going on. Our very first pattern that we've got going on here is the pattern 3, 7, 11, 15. So I've got two parts to this question. My first part is state the next 3 terms of this pattern. And the second part of my question is describe the pattern in words. So there's 2 things I want us to do here. I'm going to do the first one with you, and then you'll try the next one by yourself. So we need to figure out what this pattern is. Now, guys, a pattern can be anything. You saw in the Fibonacci sequence that we were adding the previous terms together to get the next one. That's a pattern. You're following the same procedure each time. You can be adding the same number each time. You can be multiplying by the same number each time. You can be dividing by the same number each time. As long as you are doing the same thing to get from one term to the next, you have got a pattern. Now, remember I said to you, if we go back up here, a term are the numbers in the pattern. So these values over here are your terms. This is your first term, your second term, your third term, and so we keep going. So if we sort of write this out in words, we could say that the third term of our pattern has a value of 11. Okay, so that is what a term it is. It's one of the numbers in my pattern. So now we need to figure out what this pattern is actually doing. And to do that, we need to look at these numbers that we have here. So I went from 3 to 7. I need to figure out how I'm doing that. So my first inclination would be, okay, well, I'm adding 4. So let's see. If I add, or if I keep that pattern going, and I add 4 to 7, do I get 11? Well, yes, I do. If I add 4 to 11, do I get 15? Yes, I do. So what I see is that my pattern is that I'm adding 4 to get the next term. And so that would be me describing my pattern in words. But now I actually need to go and state the next 3 terms. So if I keep this sort of idea going and I keep adding 4, 15 plus 4 is 19. 19 plus 4 is 23. 23 plus 4 is 27. And so I've got the next 3 terms of my pattern by continuing the pattern or the relationship that I saw. And so this is how we need to approach patterns. We need to look at the pattern that we've been given and decide, am I adding values? Am I subtracting values, multiplying, dividing, squaring? What am I doing to get from one term to the next? And Lunofefe has put a nice explanation there for you. We're starting with 3 and we're adding 4 to get our next term and our next term and our next term. All right, so we are increasing by 4 here. So I'm just going to stop. Anyone take a screenshot? And if anyone has a question at this point, now is the time to raise your hand. Otherwise, guys, remember, you put your questions in the chat. We see them, we answer them, we deal with them. We don't just ignore you when you put your stuff on the chat. We do try and take note of everything that's going on. We shouldn't miss your question. Otherwise, just keep asking. So again, raise your hand if you have questions. Otherwise, you're taking a screenshot. Lemuel?
I just wanted to ask if like I'm gonna do this in the exam because in my school these algebraic expressions.
I can't really hear you. Try and hold the microphone, the speaker a bit closer to you.
I wanted to ask if I was gonna do this in the exam because in my school it's really algebraic expressions.
Okay, I didn't hear the last part. I just heard, is this in the exam? Yes, number patterns is in the exam. Obviously, it depends on your school. If you haven't done it yet in your school, it might not be in your exam, but at the end of the year, you will have number patterns in your exams, yes.
Yes, okay, thank you.
Yeah. Right, guys, I'm obviously going to do more examples. I would never just give you one and then move on from that. Yes, that is 100% a way that you can get the term. So subtracting term 2 and term 1. So 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is 4. You can absolutely do that as well. My inclination is always to ask myself, what am I adding? But you can work it, I don't want to say backwards, but you can work it like that as well, which is absolutely fine. No problems whatsoever. Okay, I'm just waiting for the last few people to take their screenshots. Right, let's have a look at another. Oh, sorry, my whiteboard just fell over on me. Let us have a look at another example. So I want you guys to look at B, and I want you to try it by yourselves. And grade 8s, please remember, I promise you I know what I'm doing. I'm never going to give you one example. I'm never also going to do all of them for you. I will always make sure that you practice it. So don't stress. I will give you ones to try by yourself. I will do some with you. Promise you, you're in good hands. Right. Right, so you're trying this. I see there's some questions on the chat that I'm just going to deal with real quick. Remember, figure out what your pattern is. And remember, guys, you just put your answers in the chat.
Yes,
and remember,
please.
There's 2 questions. Describe it in words and give me the next 3 terms.
You guys are doing so well, my people. Well done. I can already see some of you giving answers, following instructions. I'm so proud of you guys.
And guys, remember, if you have questions, they need to be specific. Telling me I don't understand or I don't get it, it doesn't help. I can't help you with that. I need to know specifically what you are confused about. Otherwise, I can't do much. Right, good. Would anyone like to raise their hand to tell me what the pattern is? Chantal?
Good evening, ma'am.
Evening.
Good evening, ma'am. So the pattern is 5, 7, and 9.
Okay, so those are the next 3 terms.
Yes. And
Yeah,
and the rule is we add 2 to get the next terms.
excellent. So here, guys, we add 2 to get the next term. Now, what you hopefully see here is that we did start with a -3. And so we do need to be comfortable with integers. -3 plus 2, if you think about your number line. So if we're sitting at -3 and we're moving right, and we're adding 2, that takes me to -1. If I'm now at -1 and I add 2, that takes me to 1. That is my next term. And so we can hopefully agree that if I keep adding 2, I'm going to get my sequence. Now, importantly, grade 8, I only asked for the next 3 terms. So those of you that gave me any more than that, you could potentially be marked down because you have not read the question. I only asked for the next 3, so I only want the next 3. That is it. Alrighty. So I want you to try question C over here. Remember, it doesn't have to be adding or subtracting. We can multiply, we can divide. But I want you to try C for me. Remember the next 3 terms, and then describe the pattern. Shouldn't see any hands yet. I haven't asked for hands. Okay, guys, there was a question about the quiz. For the life of me, I can't find it now. Someone sent me a direct message about the quiz and not being able to access it. Please just remember that quizzes are on Wednesdays, so you will not get a quiz today. If you're having problem accessing it, you might need to check your network. You might need to check that you've logged in correctly. And if you're still struggling, you need to send a message to Watobe's customer service help desk situation.
Yes, definitely, because the quiz of last week should be working and you should have access to it. So maybe try, when you don't have load shedding, try to access that link again and you should be fine.
Okay. Anyone like to raise their hand? Bonolo.
Good evening, ma'am.
Evening.
So, ma'am, the next 3 terms are 32, 64,
Yeah.
128.
Good. And how did you get that? What was the pattern?
We multiplied by 2 to get the next terms.
Excellent. So we see here that we are multiplying by 2 to get the next terms. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And so if we keep that pattern up, we are able to get our next 3 terms. Very nicely done. Right, I don't know how many of you got screenshots of B, so I'm just going to leave that there for you to take your screenshots. I'm trying to do a lot of multitasking here and answering questions, but I'm going to do my best. So if anyone has any questions at this point, now would be the time to raise your hand. Okay, so I'm not seeing any hands. I'm assuming we're all okay. I'm just waiting for everyone to take screenshots. Penny, there is another way of writing a rule. We can actually write an algebraic like expression to describe it. But we're going to get there. Right now, we're just using words to make sure that we understand what the rule is. We're going to get to different ways of expressing these rules. Right, guys, I want you to have a look at D. Actually, let's do D and E and tell me the next 3 terms and what the pattern is. Remember, you're doing 2 questions now, so label your answers D and E. And guys, just think very carefully. D, you're going from -1 to -3 to -5, so you're getting more and more negative. So just bear that in mind when trying to figure out what your rule is. Good, I'm seeing some good answers coming through. That's very nice. Keep them coming. I don't think I've seen anything for E just yet. Daniel, I like your answer, but I don't know if you mean for D or if you mean for E. I'm not too sure why there's hands. I haven't asked for hands. Daniel, good, well done. All right, I'm giving everyone another minute or so because I see that we still are having a look at E, which is fine. Okay, E is a tricky one, so if you're feeling a little bit confused, don't stress. We are going to do it. It is a little bit of a harder one. Right, but let's start with D. Who would like to raise their hand to explain D for us? Tahira? There should be a pop-up to unmute yourself. There you go.
Hi. So, you add -2 each time, so it would be -9.
Yeah, keep going.
Negative-
Sorry. Yeah, -9.
-11 and
Good.
-13.
Perfect. Well done. Excellent. Okay, so guys, exactly. Now, Tahira said you add -2. That is absolutely fine. I have got no problems with that because that is exactly what you're doing. When you were saying we're adding a -2, remember, if we wrote this out mathematically, we're adding a -2. We know that a plus and a minus together actually means minus. So you can say add -2, or you can write this as subtract 2 each time. It doesn't matter. It means the same thing. So as long as you've gotten across the fact that you are taking away each time, no problems. So if we say -1,
No, it's me. I'm just saying well done to Tara. Well done, because I saw the smile on her face when she got that right. I was like, oh, that was so I felt that. So well done. I'm so happy of your enthusiasm.
yes, definitely agree. Okay, so guys, adding -2 or subtracting 2, it both mean the same thing. Absolutely fine. All right, so as long as you get across that -2, you're sorted. Tohira, very nicely done. Excellent. Right, sweet peas, who's going to help me with E? I'll make this smaller in a second or two for you guys to take screenshots. Penyo, yes, tell me.
Okay, so the rule for E is that you can see from 1 to 4, you add 3, from 4 to 9, you add 5, and from 9 to 16, you add 7. So the rule is that you add the recurring odd number. The next three the next 3 sequences would be 25, 36, and 49.
Good, well done. I'm interested that that's what you guys picked up on, and a lot of you picked this one up. So very nicely done. So guys, essentially what we're doing is that each time we go from one term to the next, we're adding the next odd number. So we're going from 3 to 5 to 7, blah, blah, blah. So we're adding odd numbers. So the way we can describe this pattern is we are adding consecutive. Now consecutive means one after the other. So 3, 5, 9, 3, 5, 7, 9, 11, one after the other, odd numbers. And that's essentially what we're doing here. So we're adding consecutive odd numbers. Now I'm quite interested because I didn't see anyone put this down. So I'm going to put it out there. This is not the only way that we can describe this. So what I want you guys to have a look at are the numbers that you've written down, or the numbers in your pattern. What do you notice all of these numbers are? And you can put it in the chat. What are all of those numbers? Let's see. All right, so they are what we call perfect square numbers. These are perfect square numbers. If we found the square root of them, we would get integers. Perfect, sure. And so another way to describe these numbers is through squares. If we said 1 squared, we would get 1. If we said 2 squared, we would get 4. If we said 3 squared, we would get 9. 4 squared, 16. 5 squared, 25. 6 squared, 36, etc., etc., etc. And so another way to describe this is we could say we square the term number. So which term is it? The first term, the second term, the third term, etc., etc., all the way up to get the term value. Now, both of these descriptions, or both of these ideas, or descriptions of the pattern are perfectly fine. You're either adding consecutive odd numbers or you're squaring the term. So the first term squared, 1 squared is 1. The second term squared, 2 squared is 4. The third term squared, 3 squared is 9. They both get you the pattern. They are both correct. It's just a slightly different way that we could have looked at the specific pattern. All right, so I don't know if anyone used the perfect square ones. From what I saw in the chat, everyone had the consecutive odd numbers, which is 100% correct and absolutely fine. But it is also important to be able to identify these square numbers, because sometimes we do put them into patterns. So it is very important that we can recognize square numbers. Right, so I'm going to make that a touch smaller so you can screenshot D and E. And then I think you guys have deserved a break. Oopsie. I'm just waiting for you to screenshot. Our brain break's a bit different today, so I'm going to do my best to explain it. We'll see how it goes. Oh, excuse me, grade 8. Sure. You wouldn't think we've only been back at school for like 2 weeks. Rightio. Okay, so here's our brain break for the day. There's your math joke on the side if you want the math joke.
Did you guys read the next joke? So confused as to why I need to put my cake in the oven at 120 degrees.
I am more impressed that that cake is not falling out of its container. Like,
you can see it sitting with the ruler.
Okay, so guys, our brain break today is what we call a ken-ken. I don't know how many of you have ever seen or used or done a ken-ken before. A ken-ken is sort of like a Sudoku, but it works with mathematical operations. And I really enjoy ken-kens, and they can get quite big and quite complex. So again, I like this as a brain break because we're doing some maths, but it's a fun way of doing maths. So I did my best to describe this in words, but we'll see how we go. So basically a ken-ken is you need to use the numbers 1 to 3 for the specific one. And we want to fill in the blocks so that if we look at the blocks, that will create a sum to give me an answer according to what I've got at the top. So I know that makes probably no sense. So if I were to have a look at, say, for example, this top rectangle here, I need 2 numbers that I add together to get an answer of 3. Importantly, though, like a Sudoku, those of you who have ever done Sudoku, you cannot repeat numbers in a row or in a column. Right? If it's already in that row, or if it's already in that column, we can't write it again. So we know 3 and 1, well, the only way you can get that is to say 1 plus 2, right? That's it. So let's put it in and let's see what we get. So let's say 2 plus 1, that gives me that 3 that I want. Now, if you have a look at this block over here, this is a block that is all by itself and we need to get a value of 3. So that can really only be 3. And now I can start to fill things in. If I know that every row and every column must have the numbers 1 to 3, well, that then means that in this bottom block down here, if I work down my column, I'm only missing the number 1 in what I've got. So there's 1. And if I know that I have to divide and get an answer of 3, we know that we would have 3 divided by 1. And so as we start to work through the operations, we start to fill in our blocks of our ken-ken. So I've done more than half of it for you. I would like to see if you guys can get the rest of these 4 remaining blocks here. Give it a try. I'm going to label these blocks. Let's call them, sure, I hope I know my alphabet. Let's call this W, X, Y, and Z. And I want the values for those letters. X, Y, and Z. Let's see if we can find them. Give it a try. So remember, look at the operation at the top, and we don't want to repeat numbers.
Let's go, my people. We can clearly do this, guys. We can do this. So I can see some of y'all answers are correct. Let's go. Ooh, I see some correct answers. Well done, guys. Well done. So well done to all of you who said W was equal to 3. So W is a 3 indeed. Well done to all of you who have said X equals to 2. Give your mark there. And well done to any of you who have said Y equals to 1. And well done to you who have said, wait, I haven't seen anyone putting Z yet. So we're waiting for Z. I see Limtwa did say Z equal to that number. It's waiting for other people. What do you think that is? There we go, my people. All of you got it correct. Z equals to 2. Well done, guys. That was a nice brain break. Nice. You nailed it. Well done.
I'm glad we understood it because king hens can be quite tricky. So really well done, grade 8. Okay, right. So let's keep describing some patterns for ourselves. Sorry, I'm scrolled the wrong way. Before I do that, Lesedi, is everything all right? I see your hand is up.
Ma'am, I don't see the block of the thing of the Z and Y and X things.
So I've just filled them in. So I've just put them in here so that we could label them.
Ma'am, I don't see. Are they on the chat?
So you should see it on the screen. If you're not seeing it on the screen, you might need to log out and log back in again.
Ma'am, I don't see it on the screen.
Okay, so you might need to log out and log back in again to get the screen working.
Okay, ma'am.
Alrighty, guys, so let's have a look at this question F. Now there's fractions here, but I don't want you to overthink it. So often with fractions, what we do is we give a specific pattern in the numerator, and then we give a different pattern in our denominator, or potentially a very similar pattern. So I want you to think about that, and I want you to, and I want you to tell me what the next 3 terms are in this pattern. So have a look, have a think. And don't let the fractions freak you out. We can deal with numerator and denominator separately. And yes, that was our break. Our brain break is always something, but that was our break, yes. Sorry, he was doing some weird things here. Fighting with me, apparently. Okay, and I like that we're also describing our pattern. Good. Right, so hands up. Who wants to help me out here with our pattern? Yo. Hey. Wonder Wonky, I feel like I haven't heard from you in so long.
Hello, ma'am.
Hi.
Ma'am, I said, since it's 3, 4, 5, I said it's 6, 7, 8.
In the numerator.
Yes.
Okay, and then in the denominators?
It's 7, 8, 9.
Good, well done. So guys, essentially in both of them, you're adding 1 each time. You've just started at a different point. In your numerator, you started at 3, but in your denominator, you started at 4. So you're adding 1 each time to both the numerator and denominator. The numbers are just different because you had a different starting point. And so our next 3 terms are 6 over 7, 7 over 8, 8 over 9, and you could keep going if you wanted to. Now, being able to recognize these patterns with fractions, excuse me, is also very important. You'll see if you do maths later on in life in like grade 10, 11, often they like to throw fractions in as a bit of a more complex, higher level type of question. And so if you can get these sorts of questions now, hopefully it means that later on in life, these dealing with fractions and patterns becomes a little bit easier. All right, I'm gonna give you one more and let's see. All right, so what are E, F, G? All right, so there's your pattern. -1, +3, -9, +27. This is a slightly trickier one, right? You guys are doing really well, so I'm giving you a bit of a challenge. I want you to see if you can tell me what the next 3 terms are and what the pattern is. What are you doing each time? Some people are already on it. Well done. We're just going to give everyone a chance. Remember, guys, only hands when I ask for hands. If you have questions, just remember to put them in the chat. Guys are doing so well tonight. Promise you now, I've got kids in like grade 11, grade 12 who can't even see this sometimes. So really nicely done. Remember, we also want the next 3 terms in our pattern. Remember, guys, generally, we also only do 1 operation at a time. So we're not going to generally do multiple operations to get our number pattern. Excuse me. It's generally 1 thing that we're doing. So just bear that in mind. Right, hands up. Who wants to describe this pattern for us? That's it. Okay, Wandle, do you want to help us out here?
Hi, ma'am. How are you?
I'm good. How are you?
I'm good. So, ma'am, what I did was I saw that I said -1. So I remembered that my teacher from school said that if you multiply a negative with a negative, it becomes a positive. So I remembered that. So I said
Good.
-1 times 3, which gave me 3. I was like, oh wow, okay. So I then said -3 times negative. No, I said 3 times -3, and then I got -9.
Good.
And then I said -9. Did I say negative? I said -9 times -3. Then I got +27.
Good.
After that, I said positive 27 times negative 3 gave me negative 81. So after negative 81, I said negative 81 multiplied by negative 3 gave me 243. After 243, I said negative 243 times negative 3, which gave me negative 729.
Excellent. Well done. Fantastic, guys. Well done. Okay, so I know there was a question about, we're a bit confused about what we're doing, but Wandler explained that so nicely. What we needed to remember was sort of our operations. We know that if we've got a negative times a negative, I'm going to end up with a positive. So the only way for me to get from -1 to +3, and then from +3 back to a negative, is if I'm timing by a negative. And so every time I times by a negative, my signs alternate, because either I will have a negative times a negative, giving me the positive, and then in the next one, I'll have the positive times the negative, giving me a negative. And so that's why I've got this minus plus situation going on. Oh, there's a moth. I hate moths. Sorry, guys. They are my worst insect animal friends.
Did you chase it away?
I'm going to throw something at it. I can't.
You're really afraid of it.
Right, okay, it's fine. Right, so when we are looking at something like this, especially when the signs chop and change, we are probably multiplying by that negative. And like Lwandle said, it's so important to remember that rule: negative times a negative is a positive, and a positive times a negative is a negative. And if we kept that pattern going, we then end up with positive 27 times negative 3, so positive times a negative, which we know is a negative, and 27 times 3, 81. Then we've got negative 81 times negative 3, negative times a negative, positive. So we've got positive 243. So this is actually the type of pattern that, I mean, we definitely could give you, but we go into depth in this type of specific pattern in grade 12, and these are really cool patterns. So Otile, in terms of how we describe it in words, we would say we multiply the previous term by negative 3. I hate writing out in words to get the next term. Also, as I've said that, I realized you were asking me for question F. Question F, we would say we add 1 to the numerator, add 1 to the numerator, and we did the same thing for the denominator, so we can say and the denominator. All right, so as long as you can explain what operation that you're doing in words, you should be sorted. Right, so I'm going to leave that there in case you want to take screenshots. You're going to see, guys, now that you're going to get a poll while that's coming up. If anyone has any questions, now is the time to ask. We are going to carry on with patterns on Wednesday and next week, so we are going to do quite a few more pattern questions, so don't stress. Didn't there question?
Ma'am?
Yeah.
Ma'am, I was just asking, when are we gonna do constant and constant difference of patterns? Are we gonna do it? That's my
Sorry, didn't hear you, cutting out. What, say it again to me slowly.
When are we gonna do constant difference and constant of patterns, ma'am?
Okay, so once we start sort of formalizing everything that we're talking about, we'll start using terms like constant difference and so on. We'll probably start that on Monday-ish, but we will chat about that, yes. Okay, Lemuel, question? I can't hear you if you're talking. You might need to check your audio option, but I can't hear you at the moment.
You can put your question also on the chat, and everybody please do participate on the poll, please. We still need like about 20% of you to do the poll.
Okay, Lwandle, I'm going to go to you.
Ma'am, I have a question.
Yes.
Will there be a scenario where we have patterns as variables?
Yes.
Oh,
Not really in grade 8, and I'm trying to think of not really in grade 8, a little bit in grade 9. They mostly come up in senior maths. So if you decide to take maths in grade 10, that's generally where we start to use variables a lot more. But yes, we definitely can have variables and patterns.